Hi students, we are continuing the problems on center of mass. So this is the last video I want to post on our center of mass. There is a few numericals we are going to discuss in this. And now when certain mass is removed, from uniform bodies, the center of mass, x center of mass is equal to total mass into x center of mass before minus mass removed mass center of mass, x component of center of mass minus by total mass minus removed mass, y center of mass also m total y center of mass minus mass removed y center of mass by m total minus m removed. Now this case we just seen x and y are the coordinates of center of mass of the plate. This plate is one dimensional, two dimensional. What we should consider? Total mass by total area is remains constant. Okay, which is cut side 2, okay, which square side of 2 is cut, which is nothing but some portion is lost. What is the total area? Total mass as I'm assuming m total. Area is equal to 4 by 4, 16, and the mass removed by how much mass? Area of mass is removed 2 by 2. Why I am calculating? We need to calculate, get the relation between mass removed and total mass. So 2 by 2, 2 to 4, and this mass removed is equal to total mass by 4. Now where is the center of mass? I am drawing the diagram again. See this carefully. This is actually the square plate. From the square plate, this is the center. Okay, from this center, other part is removed. Okay, this part is removed. The length of this section is 2 centimeter. And width of this section is also 2 centimeter. Now initially the center of mass locations are 0, 0. Removed mass center of mass location, this is at the center of this uniform plate, right? The center of mass location are from how much distance? It will be 1, 0, right? Now let's solve this expression. Y center of mass is equal to m total into y center of mass before is equal to 0 minus mass removed is equal to m total by 4, and after that also y center of mass 0 by m total minus m total by 4, it is equal to 0. There is no change in y center of mass of this plate. Let's see x center of mass, how it is changing. X center of mass is equal to m total into 0 minus m total by 4. What is the next equation? Next center of mass 1 by m total minus m total by 4. Now it is equal to minus m total gets cancelled, and 1 by 3 is remaining. Next center of mass of remaining part is minus 1 by 3. So new center of mass is y center new. The new center of mass coordinates are minus 1 by 3 comma 0. Okay, these are the coordinates. Let's see other question. Okay, wait a minute, I'll do one more question. This question we will do first, and then we will go to the other question. Now this is question. A uniform disk is 2-dimensional. Surface mass density or linear mass density or volume mass density. This is surface mass density, mass per unit area we should consider. Now what it is done, mass is a whole of radius r/2 to be cut out from the left part and is placed on the right. Okay, mass removed and mass added on the other side. So this case is in this kind of problems, it will be y center of mass is equal to m total into x center of mass minus mass removed into x center of mass of removed body plus mass added into x center of mass of added body by m total minus m removed plus m added. Array, it is x center of mass. Okay, this is x center of mass. Similarly, y center of mass is equal to m total y center of mass minus mass removed into y center of mass of removed body minus m added into y center of mass of removed body by m total minus m removed. M removed is mass removed, m added. First, let's find the coordinates. I am drawing the diagram again. This is the ring, say this is the disc. Okay, that's why it is fitting. And from this, one section is removed. Okay, that is kept on the other side. Okay, now this is diagram is not so accurate, but we try our best. Now I am changing the color of removed part. Removed part is black. Okay, and here it is added. Okay, now what is the removed total center of mass position? Initially this is the origin 0, 0. Removed part coordinates are where the center of mass of this will be at the center, and it will be minus r by 2 is the distance from here to here, so minus r by 4 comma 0. Okay, why minus r by 4? This is okay, it's not minus r by 4. It is r radius from here to here, r by 2 minus r by 2 comma 0, and mass added, where the mass is added, r by 2 comma 0, because from here to here the radius is r, it is exactly one quarter of the radius. Okay, now the formula we directly do. Now what about x center of mass? Y center of mass 0, removed part 0, added part 0, initially 0, so there is no change in y center of mass. Y center of mass remains as it is, new center of mass. But what is the change here? X center of mass will change. Let's find the x center of mass. X center of mass is equal to, new x center of mass is equal to total mass m total into initially 0 minus mass removed into what is the position of removed mass, minus r by 2 plus mass added into what is the position of mass added, r by 2, and m total minus m removed plus mass added. We don't know mass removed and mass added, we should get. So total mass by total area is constant, it is equal to pi r square, which is equal to mass removed. How much mass is removed? Radius is equal to r by 2, it is equal to pi r by 2 whole square. M removed is equal to m total by 4. Whatever removed mass is added on the other part, so mass added also equal to m total by 4. Now if you write the equations, m total into 0, 0, minus of minus plus mass removed is equal to m total by 4, and from here I am substituting, into r by 2 plus m total by 4 into r by 2 by m total minus mass removed is m total by 4, mass added is m total by 4, it gets cancelled, and m total also gets cancelled. R by 8 plus r by 8, it is equal to r by 4. Okay, the center of mass is shifted to r by 4th position. Now new coordinates are plus r by 4 comma 0. This is the center of mass position. Okay, removed and added cases. Now determine the coordinates of next question. Determine the coordinates of center of mass of thin homogeneous plate having form a rectangular side of radius r and with radius r is cut. Now first scene, let's see the whole plate. So this is a whole plate. Whole plate center of mass is here. No, this is the origin. As per him, the center of mass will be at middle. Middle is, what is the width here, r, and the height is 2r. So at r by 2 comma this is the x-axis, right? R by 2 comma 0. This is the position of center of mass. Now there is mass removed. How much mass is removed? It's removed like a circle, semicircle. This mass is removed like this, along the same line. Okay. Now this is a disc. Mass is removed not from the plate. If the mass is removed, what will be the mass removed coordinates? It is disc center of mass coordinates are 4r by 3 pi comma 0. If you have any doubts, you can go back for the previous class. It is semi-sphere, and 4r by 3 pi is the center of mass coordinate for disc. Now this is total mass. This is mass removed. We don't know what is total mass and what is mass removed calculation. Total mass by area. Area is equal to 2r into r, which is equal to mass removed by area is equal to pi by 2 into r square. R square gets cancel, and mass removed is equal to pi into total mass by 4. Okay, this is mass removed. Let's write the equation. Will there be any change in y center of mass? Because 0 and 0 y center of mass, there is no change. X center of mass is equal to m total into x center of mass. X center of mass is equal to r by 2 minus mass removed into, what is the position of center of mass? 4r by 3 pi by total mass minus mass removed. Now total mass I am taking as a common, mr is equal to, and m total I am taking as a common factor, r by 2 minus pi by 4 into 4r by 3 pi. 4 gets cancelled by total mass. If I take out common factor, 1 minus pi by 4. Okay, now m total gets cancelled, and r by 2 minus pi also gets cancelled. It is equal to r by 3 by, both are same, smaller capital, 1 minus pi by 4. Okay, it is equal to r by 6 into 4 minus pi into 4, and 2r by 3 into 4 minus pi. This is the position of new center of mass of x new center of mass. Okay, we can solve this case also, but as like the previous cases, I have to take this as a origin 0, 0, where initially read the question carefully. Show equal metal plate L which is outside of A is removed. It is little bit tricky than other problems. Try solving this. and we'll check